Możemy zaczynać. Więc... Hello. Hello, my friend. My name is Dawid. I am a developer, surprise, surprise, working in the field for something like 8 years. I have some experience with team leading, project leading. Also, I am an active community member. You can meet me at various local events and meetups. And apart from that, I'm a semi-teacher with an organization that is called Little Bit Academy. I am teaching kids code and design, actually with that girl over there. So yeah. And I am working for Clear Code, this company here. You can meet us at second floor if you want to know something about working with us. We do ad tech, we do microservices, high traffic, high performance programming. If it rocks your boat, just visit us at our stand. Also, 30 seconds about the second thing I am organizing, which is called art.exe. Did you know that you can do art with code? There are several artists who use code to create very nice stuff. So you can find it on Facebook, and that's all. You can ask me about it later. We are looking for people interested in that stuff. Okay, back to the topic. I have a lot of experience with legacy code. Since the early days of my work, I was working in PHP, which is famous for legacy code. But what is legacy code? Let us define. Is legacy code an old code? Sometimes, but not always. As a matter of fact, you could be writing legacy code today if it's not maintainable. So yeah. So legacy code is bad code. Yes and no, because many legacy systems are indeed old and they are successful. They are working on production for several years. So yeah, they are stable, they are making money. So is this bad? Nope. But what we can for sure say about legacy code is that it's not maintainable. It's hard to make changes to it. It's hard to refactor. It's hard to do really anything sometimes. So why am I even talking about this stuff? That's because, one, I have a lot of experience and a lot of mistakes, and I want to tell you about them so you can learn from my mistakes. And two, it's hard. Working with legacy code is usually harder than on greenfield projects, but it's challenging. And you can really learn and be a better engineer just with working on some legacy code projects. Okay. Another thing is it's gonna happen to you. Most of us are developers here, right? Who is a developer? Okay, yeah. And we write new code every day. And there will be a time, I think, that there will be more old code to maintain than new code to write. Of course, you can always do a job switch. When you see the legacy code in your company, it's always an option. But I wouldn't really tell you that it's a good idea, because the experience you get is something that you won't never get in a greenfield project. So let me take you about what I did wrong when working on legacy code. I will tell you 3 stories, and then I will tell you what I should have done instead. The first story and the first mistake was writing documentation. You'd say, why was that a mistake? Take a note that the documentation is in quotes here. Several years ago, I was working on legacy code with my friend, and it was written in PHP 4. PHP 4 is old, very old. It was when PHP started being object-oriented, and people didn't really know what to do with that. Now, a disclaimer. Not everyone is as open as me, and I will not mention any companies, any project, and any developer names. So I had to switch them in my stories. So me and Samuel L. Jackson were working on that PHP project. And it was really hard to work on it. There were a lot of bugs. Changing anything just broke something way elsewhere in the code. So our solution is, if we figured something out about this code, we wrote it in the documentation. And that documentation was sacred. You had to read it all the time and maintain that documentation. We weren't maintaining the code, we were maintaining the documentation. And if you were not maintaining a documentation, you will face the consequences. So let me show you a couple of examples of what was in that documentation, right? The naming of variables uses abbreviations, right? So you didn't have something like order process. You had OP or OP2 and things like that. We've deciphered some of that stuff, but yeah, not everything. Most of the variables were globals, and you weren't allowed to touch them, never ever. Even some of the files were untouchable because everything in there was undecipherable, and we didn't want to break anything, so it was just left alone. Yeah, remember variable names? Database fields were even worse. So, welcome to hell. This really wasn't effective. We started every day all happy and such, and wanted to work, but it was always the same. So, why was that bad? Well, documentation is okay, but that wasn't a documentation. That document was more of a meme we shared around each other and told about it at conferences. So documentation is okay, but it's part of the solution because you need to maintain the code you are writing. And we were just writing stuff in the documentation and copying the code when we wanted to change something. So we were making the legacy code base bigger, not writing any tests, not refactoring anything because we were scared. And we should have implemented unit testing and then refactoring. Okay. Second story. The second story is when I became a hero developer. The problem was another legacy system, but it was legacy as hell. No unit tests. Well, no documentation, old environment, very old back office. The back office for that project was written in the 90s. High traffic during the day, and highly competitive business. So no downtime allowed during the day, ever. So we can post updates only during the night. And we had 24/7 SLA. That means that the client could call me on my personal phone in the middle of the night and tell me about a bug that needs fixing. Which he rarely did, but I remember running out of a cinema and finding nearest Wi-Fi to fix some stuff. And I was the only maintainer. And this is a big mistake. it sounds impressive. Very bad code, very hard project, and I was the only one working on it. But it's not a good thing. The hero developer, it's not a good term. It describes a developer who has a lot of responsibility and deals with all the hard stuff. But hero developers get burnout a lot. They leave work always late. They sometimes come early. They basically live within the company. And I was basically the same. I was proud about it, but it wasn't healthy for anyone because the project wasn't refactored at all, basically. I didn't have time and energy to write any tests for it. Docs? What docs? I was the only one, so I could just write docs to myself. And the buzz factor of the project were equals 1. You know what the buzz factor is? Okay, basically it's a rule that if your developer on his way to work was hit by a bus, will the project still be maintained? If it's a 1, there is a 1 developer. So if I got hit by a bus, the project would stop or just be on a hold for a few weeks until somebody deciphered all that code and rest of the stuff. At some point, I had to give that project to someone else. And as you can imagine, he was not happy about it. He was not a hero developer. That guy basically wanted to leave the company because of that. So I got the project back. What should have we done? We should have implemented unit testing and refactoring. And that's a we, not me. Okay, last story. Let's write it again. The problem was a common one. Did you ever work in a company that has had its own framework? Yeah. Having its own your own framework is great, right? Instead of community maintaining it, you can maintain it yourself and work. So that framework was deprecated, and a lot of stuff in it was deprecated as well. We were using old technology. We couldn't use the newest stuff in PHP. And that was bad because people didn't want to work on it because they were not learning anything new. And the code was shit. So the management came up with the solution. Custom Company Framework 2.0. They assembled a team. The team was very skilled developers. They knew a lot about frameworks. They've used a lot of frameworks, so they knew how a good framework looks like. But could they build it? Was another question. They were working on that framework for 2-3 years. The repository for it was private even. So yeah. And when it came to the big reveal, we got something like that. It was a framework, it was working, it was crap, but it was working. Now, you can make the argument that this isn't a framework, it's already product. And yes, we had some modules that you don't have in your everyday framework, because if you have a framework, you have something like this. So you build modules to basically make it usable. But we should have written those modules and not something like that. So yeah, surprise, surprise, now it's deprecated as well. I'm waiting for 3.0. I'm not working with them anymore, but yeah. Okay. Most of the time, when we work on legacy project, it's really better to fix stuff. Because let's come up with a scenario. This is a chart. It's not a scientific chart. It's very unscientific, but it works. This is your capacity before writing new framework. This is your capacity when you have some of your team solely on this project. And this is a technical depth of the old framework. When we go here or here, the technical depth is bigger than the capacity. Work stops. You are unable to do anything because the regression is too big. And if we, instead of working here on the new framework, we could just lower the technical depth to pay it, because technical depth has a way of growing exponentially. So yeah, what should have we done? You should be seeing a pattern by now. Yep, we should have unit tested the framework on or everything and refactor it. Now, you could argue that the code is already tested because it's most likely years on production, so it's tested by the worst kind of tester imaginable, the end users. And yes, it is tested until you have to change something. Because changes equals regression, and regression breaks things. So it's not a big of a deal when you have tests in place, because if you break something, the tests will most likely catch it if the coverage is good enough. But most of the legacy projects have no testing at all, or very little of it. And if there are no tests, the code is not testable either, because people are not writing clean code, and not caring about, not having too many dependencies, so they can test stuff and control what's going on inside the class. There's more to worry about. We will not meet standards because they change. And for example, you remember GDPR or RODO in Poland? Several companies had such a bad projects that they decided to pull out of Europe entirely because it would cost them more to implement the GDPR rules than to just cut the market entirely. There are many dependencies. Most of them will be deprecated. If they are not taken care about, it will only get worse. So if you have all dependencies, the security is at risk because projects get end of life, no more security patches. That in turn has an effect on the project stability. So what can you do? Well, we should start with tooling. The first thing to take into consideration is if you have the tools for the job. I'm talking about tools very accurately here, because good IDE and debugger are making a world of difference. Some people don't set those things up in legacy projects because they think it will not work. The debugger will not work because project is legacy. The IDE and linter will not work because all the code will be red. That is false. You can configure it and it works really well. I was working with JetBrains IDEs for a long time, and all of them were really good when working with legacy projects. Plus, you had refactoring built into the IDE, and it works really well. Also, if your language is not compiled, it's a nice idea to use some libraries for static analysis. For example, if that was PHP, I would recommend you to use PHP stan on Prophecy. Okay. Now, there are two things we will be doing when writing changes for legacy code. We will be adding new code, and we'll be changing existing code. Adding new code is simple. Just use TDD. But use that TDD, write those tests, because lack of tests is something that most likely got you in the problem in the first place. Separate the new code base. That means when I was working on one legacy system, I've had a separate sources folder with modern and clean infrastructure, and the old sources folder was just referencing classes and modules from that folder. When I was working on something new, that is, and everything there was tested. But the usual thing that you have to do is changing the existing stuff. So your mission should be to make code maintainable. So if you are changing something, you should test around it and refactor it if you can. Use the Boy Scout rule, right? You clean around the fireplace that you are in. But how? Refactoring is the answer. Refactoring is a process that means changing the structure of the code without changing how it works. So the code works the same, but it's much cleaner, much more maintainable. You could refactor without testing, but then you would be making changes to the code without testing, so you are not sure, yeah? And that is a really bad idea. So never, never, ever do that. You have to put your project in a vice. You know, vice, something like that. I didn't know that was in English, vice, so yeah. The vice, to go back to it, is imagine your project as something with many moving parts. When you want to focus on one thing, you'd place it in a vice and have it not move anywhere. You can do something like that with tests. You test around the stuff, so you are sure nothing will break if you change something. Ideally, you would test everything around the refactor, but we all know that wouldn't be possible. So what should we test? I am going to tell you about 4 rules about that. So let's go to an example. It's a really simple one. By the way, I'm using PHP for examples because it has a Java-like syntax, and I know very well PHP and JS. So showing you that in JS would not be a good idea. So we have some order processor. It has some order list. It processes orders. Yeah. And you can add orders to order processor. That orders are set as processing, and they are added to order list. And there are many, many other lines of code. Okay. So if you want to change that function, what would you test? First thing is writing the characterization tests. So what do I think the code does? And write in test. I think that code gets an array. I think that code gets an array of orders and set the statuses of all those orders. The order list should change. And maybe we should even check if the order list has only processing orders. So test that like an invariant. But that's not enough. We have to think about the effects that the change will make. So that code, what does it change? Let's see. We have our add orders method. It gets orders, it changes the order list. Where do we get the orders? This is the caller. So get unprocessed orders, gets the orders, uses the add orders, and then the order list. Is that all of it? No, because as you can see, the orders are passed like an array of objects. So they are a reference to an object, not a clone. That means we do you have effect in this way as well. So where should we test? We should test here because we are changing something over there, and we should test here as well. Okay. But is that enough? No. There is one more thing, because we were looking at our code as something flat. But when we are using object-oriented systems, we have inheritance in place. So there are, apart from inheritance, global objects, hidden seams, hidden dependencies, which we have to take into the account. There are subclasses, which will be affected by that, which might be affected by that change as well, and superclasses. We have to think about them as well, because we don't want to break the LSP principle. You know solid? Yes. I would not talk about it now, but maybe later you can just ask me if you don't know Liskov substitution principle. Okay. One last rule. You can take a step back. We are looking at our code locally, but what if we looked what uses all that code and found out something like that? What if all these orders are only in one part of the system, and this is the only point of contact to the rest of the program? If that is the case, we can just test over here. And if we have this tested in only that one place of contact, we can refactor everything here without worrying. So we now know where to test. But to test something as a unit test, we have to bring the code into something called a test harness. So you have to make an instance when you are testing an object. You have to make an instance of it without dependencies. You have to mock some stuff, and you have to have control of what's going on inside the object, more or less. But that is easier said than done. We are working on legacy code, so there can be a lot of problems with dependencies. So we should refactor. So we want to test so we can refactor, but we have to refactor so we can test. That is a problem. But it's not unsolvable. Okay, so we have dependencies we have to take care about. We have side effects we have to take care about. There are globals that we have to instantiate if we want to test and control as well. And the worst thing of all, monster methods and God objects. So time for SpreadIT developer survey. What was the most lines in one class you have seen? 500? Okay, I will just raise your hand and, okay, 1,000, 2,000, 4,000, 8,000, 16,000. Okay, so between 8 and 16,000. What was your number? 10,000. Hell of an object. I hope it was not with inheritance, so you didn't create subclasses of that. Oof. Okay, so yeah, it's problematic. And sorry, by the way, for bringing out those traumatic memories of big classes. So here's a cute cat. Everything okay? Great. We have a lot of tools at our disposal. For example, we can use some design patterns which are created for doing stuff like taking out the change we want to do, so we can put it in the test harness. We can use variable sensing, which I am going to tell you about. or something which is called breakout method object. There is something like Scratch refactoring. I will going to tell you about that as well if we have enough time. We'll see. And a lot more. So let's go to those design patterns. One of the most simple ones is a sprout method. Sprout method is just a simple method which is at the start or the end of the method you want to change. So we want to change that at orders, that it checks if the orders are unique and are not being processing as well. So we can just create another method. So we are not changing the body of that method. Just use your imagination and think that this is not for lines, but 400. Okay? I wouldn't want to have 400 lines on that slide. So yeah. What do we get from that? We have the separation between the change and the rest of the code. So we can test only that new method. Of course, there could be problems with instantiating that object, but we can make that method static. If it's a pure function that it just gets and spits out values with no side effects, we can just make it static and test it that way. Or we can use a Sprout class, which is a class that is instantiated instead of that static method or that object we can't test anymore at the time. Even better, we can use wrap method. So what you can see over there, I've changed at orders and separated it into two parts. Some new logic I've wanted to add. I've wanted to add logging and the private method, which is basically the same as previous add orders. So we have the same method, which is not touched, and a new method we could test. We could even use a class to wrap around the object, but this one has a major disadvantage, and maybe someone knows what it is. It uses inheritance. In the legacy code, we don't want more inheritance than we need already. So instead of doing that, because we inherit from the order processor and we are just changing a method, we could create a decorator for that. So it does the same thing, but it gets the order processor as a parameter and serves as something like the proxy around the object. It decorates it. So we have to just get the interface from that processor and realize it the same way, but we can change some stuff before we create the processor. And we don't have to inherit from it. We just get it in the parameter when we construct the object. Okay. Now, this is cool and all, but what if you have to change something in the middle of the method? You can't just do it in the front or in the back, in the end. You can't test them, so you have to, because how do you test something like that? Yeah. You can't really do much stuff because the method could use some internal arrays. It could internal variables. It could make a lot of stuff. It could use some globals, some hidden dependencies, and things like that. You could use variable sensing. It's a simple method which lets you to write tests for a very complicated code when you have no control of what goes inside of it. So let's think that we have that method. It has a lot of lines of code here, a lot here, and the orders are created somewhere there, destroyed somewhere there, and not in the parameter. How would you check with the test what was changed and if that if works. It's a little bit hacky, but it's good start before refactoring. You create a variable, which is a public field on the class you are testing, and you treat it like a flag. So it's a false on the start, and if it gets set to true, we know that in the test we run through some kind of a code path. So for example, you could have something like this test. By the way, people laugh sometimes. SUT means system under test. Okay. The last thing I wanted to tell you about, okay, not the last, but is breakout method object. So let's say we have that 400 lines of code method, and we want to test it somehow, but it's hard to instantiate the object that it belongs to. We could take this method and make it into a class. So see what I did there. I've copied the parameters of the method, moved them to the new class constructor along with the reference to the parent object, or the object which the method belongs to. And then I have add orders, but all the parameters are kept as a class fields. That lets us test the method by just instantiating this. And you could say, okay, but you still have to instantiate the order processor, right? So the first thing you should do is to extract the interface from that object so you could mock it. It doesn't change anything, it will not break anything, so you can just do it. Now, we have the interface here. We can create an instance and test what we like. And using this is not changing much as well. Okay. How much time do we have? We have 12 minutes. So, scratch refactoring. It's a method I wanted to tell you about. Not many people use it because they think this is not a good idea, but I wanted to just tell you about it because I think it's really useful. You could refactor your code without writing tests to explore the code. If you have a monster method, you should try to maybe refactor the method and see how the structure of the method works. That way, you will discover all the globals, all the hidden dependencies. But the hard part about this refactoring is you have to throw it away. This is scratch refactoring. You just want to know the object because this is the first time you are seeing it, and the method doesn't fit on your screen, even 2 screens or 10 screens. So to understand what is going on, you will refactor the object without tests, try if it works, but throw it away because it could introduce very serious bugs. And then have a strategy for refactoring and testing. And we haven't really gotten to refactoring yet. I know about that, but this is a really, really big topic. So, and the refactoring is very different in several languages. You can, especially when we are talking about getting rid of the dependencies, many languages have different mechanisms that let you do that, so you can test. You have reflections, some languages are dynamic, some are not. So I've decided not to include that in this presentation, but I will recommend you 2 books which are amazing about that topic. The first is Working Effectively with Legacy Code, and you should start with this one. It's an amazing book. It's written like a FAQ. So, for example, a chapter is called "What if I can't instantiate the object because it's too big?" Or I don't know my program structure. Or there is even a chapter which is called, it's not going to be any better, we are tired. Another book which is great is this one. This is a classic. If you don't have that book, I would recommend you buying it. It has a lot of refactoring methods that are really useful and not really that simple. So it's a good buy, and it's not really expensive. So if you are dealing with legacy projects right now, good luck. If you are not, I recommend that you try if you have the occasion. It's a hard adventure, but it's an adventure that is worth taking. And don't give up. Don't just go to the mistakes I wrote because I didn't want to change the code for the better. It takes time, but it pays. So yeah. The last thing I just want to mention, the guys upstairs and me have a competition for you. It's here. Do you know what a code golf is? Great. So code golf is a competition that you have to solve a problem, write a program in the least possible amount of bytes, least possible amount of bytes. And who will, you have 5 languages to choose from. You can do it on your phone. There is a compiler and it will test your code. You can write it in Ruby, Python, PHP, Node.js, and Bash. So I recommend trying. Of course, there are prizes for that. Feedback, as always, is very welcome. If you have something to tell me, you can either catch me something around Clear Code stand during the conference or there. Do you have any questions?